In this video, we are going to look at sketching polynomial graphs. Specifically, we're going to look at the higher order polynomials. In a previous section, we already looked at graphing quadratics. So that would be anything where the highest power is 2. We're going to graph things that have maybe cubic terms in them, or x to the 4th power, x to the 5th power, etc. And polynomial means usually these functions are going to have several terms. Polynomials are always smooth and continuous graphs. So because of that, we can use a little 4-step method we have here to do sort of a quick sketch. We're not going to do very precision graphs of these polynomials. We're just going to do a basic sketch to give us an idea what the shape looks like. So the steps we want to take when we are sketching these polynomials is, first up, we want to find the x-intercepts. And finding the x-intercept of a polynomial is just like finding any x-intercept. You put 0 in for f of x or 0 in for y. Sometimes we call these in a polynomial the zeros or the roots of the equation. Next up, we want to look at what is the multiplicity of each one of those roots or each x-intercept. Multiplicity is the number of times the associated factor appears in the polynomial. And you'll see what that really means in a minute when we do an example. But anything that has an even multiplicity is going to just touch the axis, kind of like a quadratic function. Anything that has an odd multiplicity is going to actually cross the axis. Again, you'll see this demonstrated when we start doing our examples. Next up, we want to find the y-intercepts. Just like any function, we would put 0 in for x and solve for y. And then the final thing, this is kind of unique to polynomials, we want to examine that leading term, or the term with the highest exponent, to figure out the end behavior. And here's what this tells us. We want to look at that leading term, and we want to decide first, is it even or odd degree? So the highest exponent, is it an even number or an odd number? And then we'll also look at the coefficient of that term, and we'll see if it's positive or negative. So what we have going on here, if you have an even degreed function with a positive coefficient, that means that the tails of that polynomial are both going to be facing up on the left and up on the right. Okay, we don't know what's going to happen in between here. This could just be a quadratic or a quartic, or it could wiggle around. We don't know what's happening inside there. But an even degree polynomial with a positive coefficient, both tails will be facing up. Likewise, if we have an even degree polynomial with a negative leading coefficient, both tails are going to face down. Okay, again, we don't know exactly what's happening in the middle here. We just know that both tails will face down. If we have an odd degree but a positive coefficient, that means that your left tail is going to be going down and your right hand tail is going to be going up. Kind of like a positive slope, positive coefficient of a linear equation, except again, in here in the middle, our polynomial could be doing all kinds of things. Odd degree and negative means that it's up on the left, and down on the right, kind of like a negative slope on a linear equation. And again, some kind of wiggling will go on inside there. So really, the leading term can tell us what our tails are doing, what the end behavior is of our function. And then if we need to, if that information we got in 1 through 4 isn't enough, we can plot some additional points or just create a t-table. Okay, so let's look at our first example. We're going to follow those 4 steps. Okay, so first up, find the x-intercept. Luckily, this function's already factored for us, so we can really just almost read off the x-intercept. But basically, we would set that polynomial equal to 0. And then we take each one of those factors and set them equal to 0. Sorry, x plus 1 equals 0. So that means our first x-intercept is going to happen at -1. Or x minus 2 equals 0, so there's another x-intercept at 2. Or x plus 5 equals 0, our third x-intercept at -5. Okay, so those are our x-intercepts. We need to talk about the multiplicity of each one of these. So this -1 root came from this factor right here, x plus 1. What is the exponent on that factor? Well, there isn't one, so basically that means the exponent is 1, so that this root has a multiplicity of 1. This 2 came from x minus 2, and this factor also has an exponent of 1, so this one also has a multiplicity of 1. And the last one, same thing, x plus 5 is just raised to the first power, so this 0 also has a multiplicity of 1. So an odd multiplicity means that it's our polynomial function is actually going to cross the x-axis at each one of those points. Next up, let's look at our y-intercept. Okay, for y-intercept, we put 0 in place of x. So when we multiply these together, we end up getting -10. So there's our y-intercept, 0, -10. Okay, finally, the last thing we want to consider is our end behavior. Okay, so we have to figure out what our leading coefficient would be. So in this case, you might say, well, x is raised to the first power, but that's not what we're looking at. We need to think about what would happen if we multiplied this back out, if we expanded all these parentheses. Now, we're not actually going to do that because that's a lot of work and we don't really need to. But we can see if we were to multiply, we have 1, 2, 3 x's. That means our leading coefficient is going to be x cubed. Okay, so that is an odd degree. And because all of these x's are positive, the coefficient would still be a positive 1, so it's a positive coefficient. So odd and positive means that on the left side, the tail will be pointed down, and on the right side, the tail will be pointed up. Okay, so we can put all this information now together and draw our picture. So first up, let's put those x-intercepts on the graph. We have -1 and +2. And -5. Okay, let's put that y-intercept on the graph, 0, -10. And then we'll sketch in our end behavior. So on the right, it's got to be pointed up, and this is our rightmost x-intercept. So from here, it's got to go up that way. On the left, it's got to be going pointed down. So this is our leftmost x-intercept. So from there, it's got to go down. And the other piece of information we know is that at each one of these x-intercepts, it's got to cross that axis. So here at -5, it's got to go across. And then it would have to come back down to touch this x-intercept. And it's got to cross there again. This time we know it's going to go all the way down to that y-intercept at -10. And then it would cross the axis again there at x equals 2. Okay, so it's not a perfect graph. We don't really know in truth how high this little bump would go. It could be lower or it could be much higher. We could plot points to get more details, but this is just a rough sketch and this is what we're looking for. The other thing that you might be asked on a question like this is they might ask you to list the intervals, the x values, where your function is positive and where your function is negative. Okay, so that just means we are taking this and we are cutting right at the x-axis. Okay, so where is our function above that line and where is it below that line? And we will use the x values to tell where it's above and below. So let's get a blue pen right here. So you can see right here, our function is all above the x-axis. So that starts at -5 and ends at x equals -1. So from -5 to -1, our function is positive. Our function is also positive here. So that starts at x equals 2 and keeps going forever and ever. So that's the interval 2 to infinity. Okay, where's our function negative? Well, oops, I ran out of room, sorry. It's negative right there. So that's from -infinity up to -5. And it's also negative right here. So that's from x equals -1 up to x equals 2. And now I kind of drew all over my pretty graph, but you saw it before we messed it all up. There's our graph, and here are our positive and negative intervals. Okay, let's look at another one. Okay, again, just get used to that procedure. Start with your x-intercepts. Again, this one's factored for us, so that's kind of nice. Okay, so we get 3x minus 2 equals 0. If we solve that for x, we get x equals 2/3. I didn't write them as ordered pairs last time, but that's the intercept 2/3, comma 0. And for this one, we get x plus 2 equals 0. X equals -2, which again is an ordered pair. Okay, let's look at multiplicities of each of these. 2/3 comes from this factor, 3x minus 2, and the exponent on that factor, there isn't any, so that means the exponent is 1. So the multiplicity is 1. This -2 comes from this x plus 2 factor, and that has an exponent of 2, so the multiplicity of this 0 is 2. Okay, so that took care of our x-intercepts. Let's look at our y-intercept. For y-intercept, we put 0 in place of x. Three times 0 is 0, minus 2 is just a -2. And over there we get 2 squared, which is 4. So we end up with -8. So our y-intercept is the point 0, -8. And then finally, we want to talk about the end behavior. So what would our leading term be? Again, this is already factored, so we got to think a little bit. If we multiplied all our x values, we'd have a 3x. And when this piece got squared, we have an x squared, so our leading term is going to be 3x cubed, which is, again, a positive coefficient and an odd degree. So that means down on the left and up on the right, just like a positive linear function. Okay, so let's put this all onto our graph. First, we need these intercepts, 2/3, 0. That's about right there. When it's a fraction, you just give it your best shot. And -2, 0. And our intercept was -8. Y-intercept, sorry. And our tails, the left tail is down. So this is our leftmost intercept. That means from there it needs to be going down. Our right tail is up. So from our rightmost intercept, it needs to be going up. And then multiplicity at 1, when we have a multiplicity of 1, that one means it's going to be across. It's going to cross the axis. So here at 2/3, it's going to cross down. A multiplicity that's even is just going to be a touch. So here at -2, it's going to touch the axis and bounce back down. And in between here, it's got to go down and hit that y-intercept. Okay, so again, not the prettiest graph, but it gives us an idea. This graph goes up, hits the axis, bounces back down, and then comes up and hits at 2/3 and continues on up. Okay, here's one that's not factored. So let's give this a try. Okay, so first step again, same thing, find those x-intercepts. It's just going to take another step or two this time since it's not factored for us. Our first step in factoring this one would be to pull out a greatest common factor. Each one of those terms has an x squared in common. And when we do that, we're left with x squared minus x minus 6. And then that factors a little further. You can factor this into x times x. And 6 would be 2 times 3. To get that negative x in the middle, we would need a minus 3 and a plus 2. So we set each one of these terms equal to 0. One of our intercepts is going to be at x equals 0. Next one at x equals -2. And this one at x equals 3. Looking at multiplicity, this x equals 0, that came from this factor that was squared. So 0 has a multiplicity of 2. X equals -2, that came from this factor, which is just raised from first power, so that's a multiplicity of 1. And x equals 3 came from our final factor that also only had an exponent of 1. So we are going to have our graph is going to touch at 0, and it is going to cross at both -2 and 3. So then let's get our y-intercept. Put 0 in for x. So we get 0 to the 4th minus 0 to the 3rd minus 6 times 0 squared, which all works out to just be 0. So that's our y-intercept, 0, 0. And then finally, we want to talk about our end behavior. Okay, our leading term is x to the 4th. That is even degree, and the coefficient is just 1, so it is positive. Okay, even and positive means that both tails are going to be facing up, kind of like a parabola, a quadratic. So we know both tails are going to be pointed up. Let's graph everything we have here. Our intercepts, our x-intercepts are at 0 and -2 and +3. Our end behavior tells us it's going to go up on the right and up on the left. And we know that we are crossing at both -2 and +3, and we are just touching at 0. So that means this graph's going to come down, hit 0, and come back down, and then hit our 3. You really use your x-intercepts as your guiding points. You have to connect those dots somehow, and the rest of the clues of the graph tell you how to connect those dots. Let's on this one look at our positive and negative intervals again, just to see what's going on. Make sure we get a little practice with that. Where is this function positive? Okay, so that's saying where is it above this x-axis? It is above the x-axis here on the left-hand tail from -∞ until we get to -2. And it is positive again over here on the right-hand tail from 3 to +∞. And where is our function less than 0 or negative? It's negative in between here, -2 and 0, and 0 to +3. A couple things to note. We had to split this one up into 2 separate intervals because at x equals 0, our function's not negative, it's equal to exactly 0. So even though it doesn't cross back over into the positive, it still isn't negative at that point, so we have to split it into 2 pieces. And the other thing to notice is that you should never have the same interval showing up on your top line and your bottom line. The pieces of your graph are either positive or negative. They can't show up in both spots. Okay, I've got 2 more examples for you. Here's our next one, example 4. Again, start off with our x-intercepts. That means we set 0 equal to our function. Oop, forgot that negative sign, -x to the 5th plus 4x cubed. Again, to solve this one, we'd want to factor. We'll look for a greatest common factor, which would be x cubed. Now we set each one of these terms equal to 0. If x cubed is 0, that means x has to be 0. And the multiplicity, we might as well just finish out. Multiplicity is 3 because there was a 3 on that factor, a 3 exponent. On this one, we get -x² plus 4 equals 0, or 4 equals x². Take the square root of both sides, we get that x has to be either plus or -2. So we have x equals 2 and -2. Now, if I could have factored this further, but we got x² gave us 2 roots, so these actually only each have a multiplicity of 1. because I could have up here factored this into, could have rewritten it as 4 minus x squared, and then it factors as the difference of two squares. So each one of these has an exponent of 1. That's why these just have a multiplicity of 1. Our y-intercept, put 0 in for x, and we again are just going to get origin for her y-intercept. And our end behavior, our leading term is negative x to the 5th. So that is an odd exponent and a negative coefficient. So that means it's going to be up on the left and down on the right, kind of like a linear function with negative slope. So let's put all our pieces together and draw our graph. Start with those x-intercepts. We have one at 0, one at positive 2, and one at negative 2. Our tails tell us, our end behavior, that it needs to be up on the left and down on the right. And we know that we're actually in all these spaces, multiplicity 3, multiplicity 1, those are all odd numbers. So in every place, it is going to cross the axis. So here it's going to cross at negative 2, come back up and hit 0, cross again, go back down and cross again at 1. So there's a rough sketch of our minus x to the 5th plus 4 times x cubed. Again, this is a rough sketch because actually here at 0, we would see this flatten out a little more in the middle. It would look more like a cubic function because we had that x cubed in there. But since we're just doing rough sketches, I think that's close enough. Okay, so in our last example, we're going to talk about what happens if you forget all those wonderful rules about multiplicity and about end behavior. You get to a test and you just can't remember, your mind goes blank. How can you approach one of these functions? Okay, so if you are asked to graph this and you can't remember anything, you need to at least remember how to do your x and y intercepts. Okay, so find both of those and then we can go from there. We can figure some other stuff out. So since this one is factored for us already, I set each one of these factors equal to 0. I'm going to get an x-intercept at x equals 1. I'm going to get an x-intercept at x equals negative 1. I'm going to get an x-intercept at x equals negative 3. And for my y-intercept, I put 0 in for x. And when I multiply all this out, it turns out that the y-intercept is the 0.03. Okay, and again, that's all we remember, the basics. We don't remember any of our tricks. So what we can do from there is go ahead and plot those intercepts that we have. At 1, 0, at negative 1, 0, at negative 3, 0, and at 0, positive 3. And then what we would do from there is we would choose some strategic test points. Okay, so we still have to remember that a polynomial is going to be basically smooth and continuous. So we know it has to hit this point right here. There's an intercept at 1. What we don't know is it going to come in from above or is it going to come in from below to that point. So we need to pick an x value out here somewhere bigger than 1. Let's say we chose x equals 3. And kind of like when we did the inequalities, the polynomial and rational inequalities, I don't really care exactly what the y value is. I really only care if it's positive or negative. If you want to use your calculator and plug that 3 in and get an exact number, you can. But what I'm going to do, I'm just going to do this quickly in my head. 3 minus 1 squared. Anytime I square anything, that's going to be a positive value. 3 plus 1 is positive. 3 plus 3 is positive. So when I multiply 3 positive numbers together, I know it's going to be positive. So over here where x is equal to 3, the graph's got to be coming in the positive side. So it's got to come down like that to our first intercept. Now, next we have to go to our next intercept, which is at negative 1. And to do that, we have to go through this y-intercept. This is a point we already know. So we know there's no choice except for the graph to turn to go up, hit that y-intercept, and come back down to our next intercept. Okay, now here at x equals -1, it might continue back down, or it might bounce off and go back up again. In order to figure out which one of those cases we have, I'm going to plug in another test point, x equals -2. When I plug -2 into my function, -2 minus 1 squared, well, again, anything squared is positive. -2 plus 1, that would be negative. And -2 plus 3, that would be positive. So when we multiply a positive times a negative times a positive, we get a negative value. That means in this area, in between the intercept of -1 and -3, our function must be negative. And now here's where we made it to our last x-intercept, and from here it could either continue up or it could turn around and go back down. And again, we test some x value to see what happens, and that's got to be an x value smaller than -3. So maybe I'll plug in a -5 up here to our original function. -5 minus 1 squared is positive. -5 plus 1 is negative. -5 plus 3 is negative. And the product of those values would be positive. So that means that our graph has to be above the x-axis. So it would continue up. Our tail would be pointed up in the positive direction. Okay, so if you forget what multiplicity and behaviors tell you about your graph, you can always use your intercepts and then plot some test points to sketch it out.